In the future, then, what is the systems engineer of tomorrow? What's he going to look like? Is he going to have to be someone that goes through school in a specific discipline? Maybe he learns a little bit about interpersonal or intercommunication skills, and then he goes out and works, and he gets certification, and now he can be a systems engineer. That would certainly work with. That's certainly the model as it exists now. But what about in the world where, to use a overused phrase, the Internet of Things, where you're going to have tons and tons of startups making things, small teams. Person right out of school is going to have to, have a lot of those skills already.
I think we're starting to see that popping up in all sorts of places. There are much smaller organizations putting together products because you can do so, because the technology makes it easier to put something out, because it's not hard to create an app and host it on an existing platform, or to come up with a specialized platform that controls your house temperature, for example.
Yes.
Relatively recent examples of products that have been appearing. They're small products, the small teams that put them together, and they don't have a systems engineering department who went off and thought about the whole problem. The whole team probably thinks about the whole problem and works on it together. Because it's a small team problem, everyone needs to play. But you probably have experts in that team who have a specialization. They know how to do the software coding, or they know how to program the FPGA, or they know how to build the carcass that it's got to go into, or whatever that might be. That you need the specialists. So I don't think we're going to lose those specialized skills, but I think some of the specialized skills are changing. And I think those specialists need to have a broader education and not just dive straight into a specialization. We end up with people coming out of school with a graduate degree in a topic that they worked on the whole way through school, and they did very little other subjects, and thus don't really know much about the other domains that other people work in. And we don't educate people broadly, we educate people in depth in a specialized subject, and there are so many options you can go and pick. Specialized option you're going to sit in that narrows and narrows and narrows your focus area, and I think that's going to need to be reflected in a different sort of education model that broadens that offers more systems engineering education without necessarily needing to have systems engineering as a primary degree as the only way to get there from here.
And an encouraging sign at INCOSE here, we were wandering through the university booth, and you'll see systems engineering, of course, but you'll also see programs in integrative management, or where they'll bring in business people and I don't know, artists, liberal arts or something, yes, along with as part of a certificate program, but it was also part of some of the degree programs as well. So the universities, I think, are trying to move that way. It'll be interesting to see where it actually goes.
Yeah, but we're seeing a lot more diverse interests. Once upon a time, systems engineering was thought to be something that lived in the defense space. Military, aerospace kind of people were the originators of today's system engineering. But that isn't the only domain, and we're seeing people coming in from transportation with a very different point of view as to what the problem set is they deal with. And it's interesting, transportation is a good example. Not just how do I build a train or how do I build a car, but how do I manage a railroad, a transit authority. There's a lot of people here from organizations like that focusing upon the systems engineering task of running a system, the metro transit for around Chicago. It's a whole system in itself. And systems engineering isn't just the greybeards. It's a collection of people across all ages. And we're seeing a lot of people coming into the industry at the bottom. But there is also a problem with a lot of experienced systems engineers reaching retirement, falling out of the other end. And we look at the bell curve, and the bell curve's got a hole in the middle. There's a gap where people weren't coming in and getting into systems engineering. They were going into their specializations, and they're experts in their own little domains, but they're not looking at the systems engineering space. And that's left a dip in the population. So systems engineering groups are finding it hard to backfill experienced people, and I think that's encouraging the oncoming population of new systems engineers. And I'm very pleased to see new members coming here, 150 new members at this occasion. A lot of them are young members. I think maybe Internet of Things is going to help and change that and bring in the possibilities of so many different things that are connected, that interact with people the way that they're used to having their apps interact with things. So I want everything. I find it great coming to these kind of events because you have a lot more free-flowing conversation about a much broader range of topics than I would do in a normal daily activity where we tend to focus. I may not focus on a narrow discipline with the products I work with, but I still do focus upon that set of solutions that my product can deliver, and not really range across all the other areas. I talk about the capabilities we have in terms of analogies, because the people I'm talking to are not electronic domain experts. So they're not familiar with the way we do stuff in the design of electronics, so I have to talk about how things work in teal and blue, or the communication between tools. I've got a tool in my hand, a cell phone, and it's enabled to do a certain job for me. In fact, quite a lot of jobs for me. But it doesn't talk to any other cell phones. It only talks to the carrier who provides me with the service. And that carrier provides another piece of the service. It knows how to communicate with all those other disciplines out there, or all those other phones out there. Another analogy that helps people to understand what we're doing when we try and connect things together. Sharing information in the same way that my telephone is capable of sharing a message with you, but I don't need to know where you are or how to find you, because the system understands where you are, because you are also interacting with the system. And because we can use those interactions, we can start to make the tools we work in our daily job more useful, in just the same way as we've got used to making the cell phones that we carry around with us an indicator of where I am and what I'm doing and how I can find somebody else when I need to.
And one step further, I mean, these cell phones, you can begin to run things, software programs, sophisticated modeling programs on if not a cell phone, then a net top, I mean a laptop, excuse me. So, you can have the conversation and even get some valuable data out of it.
Yes. Yeah, I can update a website from here and share information with a whole number of people, because that updated website conveys it to a lot of people. But I can also tell those people, hey, you should go have a look at the new web page, see what's there. I've got information to do that. But the work was done in the tool. I drove the tool to go and do the work. But then let's use those tools to help communicate.
Perfect. Nice place to end.